Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into your homework here on inverse functions. All right, so here we go. Number one, explain why the domain of the inverse sign, or sine inverse, y equals sine inverse of x here, is negative 1 to 1 inclusive. All right, which is from negative 1 to 1, any number between negative 1 and 1. Well, this goes back to how we restricted the sine function. So in class, I talked about how we had to restrict that. So let's just draw a little concept diagram of the domain and the range of this restricted function because we need the inverse to exist. So we had to restrict the domain. Now, typically the domain of the sine x is all reals, but to make it have an inverse, which is a function, we need to restrict it. And our restriction was from negative pi halves to pi halves. So our restriction here, if you recall, and you can look at your notes if you like, is from negative pi halves, right, to pi halves, okay, closed, right, which means any angle in there from negative 90 degrees to 90 degrees. And those angles are either in quadrant 1 or quadrant 4, as we were talking about. Now we know the max of sine is 1 and the minimum is negative 1, so the range is from negative 1 to 1. You can write it like this, or you can write it like negative 1 less than or equal to y less than or equal to 1. Okay, so this is your minimum and this is your maximum. Okay, now that's for the restricted function. So we make sure that the inverse exists. Make sure it's 1 to 1 and it passes the horizontal line test, and make sure that the inverse sine function is a function. Okay, so you put one in, you have one input, and then you have one output. So that is a function. Well, the inverse sine takes any number from negative 1 to 1, all right, and sends it right back to the angle. So the inverse sine, so this right here, this function, or we call it arc sine of x right here, takes any number, all right, in from negative 1 to 1. So now this becomes the input. So the domain now is this. So now this becomes the domain, okay, and sends it back to the angle. So the range now is any angle from negative pi halves to pi halves. So that now becomes the range of the inverse sine. So they remember for inverses here, the domain and range switch. Okay, so the domain of sine x, going back to the beginning, is from negative pi halves to pi halves inclusive, which means it includes the angles. Right? The range of sine x is from negative 1 to 1. It has a minimum and a maximum. And any number in there, like 1/2 or root 2 over 2, let me write them down. So the numbers like in the range of sine are like 1/2, root 2 over 2, as you guys know, root 3. You guys have seen on the unit circle here. And plus or minus, by the way, positive or negative. And then any number in there, okay, can be sent through the sine inverse function. Now it becomes the domain of that inverse. And the range of sine x, inverse sine x, is the angle, any angle from negative pi halves to pi halves. So the domain and range switch. There we go. And that's it. So you can't input any number outside of negative 1 to 1 in the inverse function. It's not defined. Okay, you're not going to get an answer there. Okay. All right. Now let's talk about how to uh, take the inverse function of some values. Now before we do that, let's draw some pictures here. We need we don't need the unit circle, believe it or not. We need some basic knowledge of the 30, 60, 90. So I'm going to draw one. Here's the 30, 60, 90 with sides 2, 1, rad 3. And of course, if we see numbers like 1 or root 2 over 2, then we're on the 45, 45, 90, where it's isosceles. So the sides are 1 and the hypotenuse is root 2. And if you remember your basic trig, which is SOHCAHTOA, that's all you really need, okay, to evaluate these things. So here we go. So this is a negative number here, tangent inverse or inverse tangent of negative root 3. Negative 3 is obviously a negative number there. And so we're expecting an angle in quadrant 4. Okay, why? Well, the restriction now, let's talk about restriction for tangent. So let's just recall everything from the lesson here. The restriction is from negative pi halves to pi halves open, okay, which means we don't include the endpoints of the interval here because it's undefined there. Okay, and as we talked about, this is quadrant 1 or quadrant 4. So if you take the inverse tangent of negative rad 3, we're expecting something in quadrant 4. Okay? All right, now let's go back to basics. Looking at the triangles here, we know just by looking at this triangle up here, that one up there, the 30, 60, 90, that the tangent, okay, of pi thirds, okay, pi thirds is 60 degrees, as you guys know, is root 3 divided by 1. All right, root 3 opposite of 60 degrees is root 3 divided by adjacent 1. Root 3 over 1, which is obviously root 3. But that's a quadrant 1 reference angle, and we have a negative number, so it has to be in quadrant 4, right? So this is not equal to positive root 3. The quadrant 4 angle there is the opposite of that, so negative pi thirds. Okay, that's a clockwise rotation, and that's in quadrant 4, and it has the same values as the tangent of pi thirds, but just opposite in sign. So we're not looking for the quadrant 1 angle because root 3 is negative here, and that means that when you input negative root 3 into your inverse tangent, it sends you back to the angle where it came from, which is negative pi thirds. Okay, so what I'm saying here is that if you take tangent of negative pi thirds, okay, you don't get positive root 3, you get negative root 3, okay? So if you take the inverse of that, you go back to the angle where it came from. Same thing for the inverse cosine of negative 1/2. Okay, now the restriction on that is different, the restriction on cosine. So let's talk about that first, just reviewing what we did in the lesson here. And we restricted cosine from 0 to pi, which is quadrants 1 and 2, as you guys know. All right, so if you look at the triangle up here, the only way to get 1/2 is to take the cosine of 60 degrees. So we know, I'm just going back to basics, that the cosine of pi thirds, right, or 60 degrees, we know it's equal to 1/2 just by looking at that, adjacent divided by hypotenuse, right? But this is a negative angle, or excuse me, a negative number here. So we're not taking the inverse cosine of positive 1/2, taking an inverse cosine inverse of negative 1/2, which puts us in quadrant 2. Okay, so we need the quadrant 2 representative here. So we're looking for a quadrant 2 angle. And so what quadrant 2 angle has a ratio of 1/2? Well, it's 2 pi thirds. Okay, so 2 pi thirds. Okay, so in other words, cosine of 2 pi thirds is equal to negative 1/2. And you can check that and verify that on the unit circle. Okay. But again, we're going backwards in our thinking. We're taking the ratio and we're asking when we take the inverse cosine of it, we're trying to find the angle that corresponds to that number. Okay, now sine inverse of negative 1. Well, so here, let's just draw the little picture here, draw a little circle here. We know at the top of the unit circle here, at pi halves, we know that sine of pi halves is 1 because the max is 1. Okay, we also know at the bottom of the unit circle, which is 3 pi halves, or negative pi halves, if you rotate clockwise right there, we know that the sine of negative pi halves is at its minimum there, which is negative 1. We know that. All right, so because of this, this inverse sine of negative 1 should give us an angle, okay? And again, it has to, the restriction here, let me write the restriction of sine now. So sine restriction. That's what I've been doing for each one here. So if you recall, the sine restriction was from negative pi halves to pi halves. And we're looking there, we're looking for quadrants, you know, typically 1 and 4, but this is not on the quadrant, it's on it's called a quadrantal angle, okay, because it's really not in quadrant 1 or 4. It's right down there at the bottom of the unit circle there, but it's in this interval, okay, and we're looking for the angle at negative pi halves. Why? Because you're at the bottom of the unit circle, not the top, okay. So if you were taking the inverse sine of positive 1, well, the answer would be pi halves. Okay, there we go. Now number 3, what's going on here? So let's take a look. Which of the following pairs of functions have the same range? Okay, which of these have the same range? So let's analyze this. Choose all that apply. So maybe more than one answer, right? Okay, so the range of sine x and cosine x, both of them, here the range, I'm just going to write down the ranges here. This one's from -1 to 1. That's the min and max. And this one has a range of -1 to 1. All right, you guys know these are the parent functions here, and they have the same range. Okay, so same range is there. So 1 is definitely it. How about the rest? Well, the range for tangent x goes infinitely up and down. So here, the range of this function, well, you know what? Let's do this. I'm just going to write it like this here. So, oh, okay, here we go. Okay, so the range of tangent x here is this set of all reals. Okay, because it goes infinitely up and down. If you go back to the parent function, the range is infinite because it goes infinitely up and down, but not for the arc tangent. Okay, this is equal to the inverse tangent, so you have to get used to the notation there. Arctangent x and the tangent of x are the same thing, but the range has been restricted. And you guys know that when we restricted this function, it's from -pi halves to pi halves open. Okay, so not this one right here. These are different ranges. The range of arc sine, or the inverse sine, is from -pi halves to +pi halves. And the range for the inverse tangent is from -pi halves to pi halves open, because you can't include the asymptotes. It's not defined there. So these are different. The range of the inverse tangent here, excuse me, the inverse cosine, we had to restrict that. So we had to restrict it. So it's from 0 to pi. And the range for the inverse sine, okay, we had to restrict that too. So that's from -pi halves to +pi halves. So if you just know your basics of each one of these, you just analyze each one, select the ones that make sense, and discard the ones that don't. Okay, so only A in this case. All right, so the next one here is we're given the inverse sine. Okay, arc sine of x is the inverse sine function. We're giving arc cosine. It says let f equal this and let g equal the arc cosine, or the inverse cosine of x. And h of x equals arctangent, which is the inverse tangent of x. I'm just re-expressing these using different notations. It says which of these functions is graphed below. Explain how you know. Okay, so notice the domain here is from -1 to 1. Okay, that's the domain. So let's kind of indicate that here. So the domain here is from a -1 to 1. That's the input here. And if you go back to your lesson, that can't be tangent, because there it's unrestricted there. So, and then here the range, if you look at it here, if you look at the range, it's from 0 to pi. Okay, just look right here. So the range is from 0 to pi. And so because of this right here, it gives me an idea that it's cosine, inverse cosine of x. So let's go ahead and just draw a little sketch here, just to make sure that you guys follow me. Now, if you draw cosine, let's pop pi halves here and pi here, and let's go up 1 and let's go down 1. Okay, so when you draw cosine here, y equals cosine x here, we know that cosine x, cosine of 0 is 1, cosine of pi halves is 0, cosine of pi is -1. So here's half the period of cosine. So there's the restricted cosine function from 0 to pi. And notice the points here. So points on the graphical map. So this one here is 0, 1. And this point here is at pi halves, 0. and this point here is at pi comma -1. Okay, and then remember when you graph its inverse, okay, you switch the domain and range and you switch x and y. So if you were to graph its inverse and you want to graph its points, okay, so this point here, so 0, 0, 1, if you switch the coordinates, that'd be a 1, comma 0, 1, comma 0. So what am I saying? I've got it. You have to switch the domain and range. So switch x and y, as you guys know. We've done that before for other functions when we were studying it. So this becomes 1, comma 0, and then pi halves, comma 0. Well, that becomes 0, comma pi halves. And then your pi, comma -1. And what does that become? Well, it becomes -1, comma pi. And guess what? They're all on the graph, okay? So 0, 1, 1, 0 is here. And then 0, comma pi halves is here on the graph. And -1, comma pi is obviously up here. So -1, comma pi. So this is definitely this is y is equal to cosine inverse of x right here. There we go. All right, number five. Okay, so let's take this step by step. So let's start off with the inner part of the function here and evaluate that and explain our reasoning. Okay, so this time I'm going to kick in the calculator a little bit. So pull in your TI-84. Okay, click on mode. I'm in degree mode here, so we can just deal with the degrees here. Go ahead and say second mode or quit out. And so I'm going to evaluate the inverse sine of 0.25 in degrees. So I'm going to go second sine, okay, 0.25, and I get 14.476, or no, 0.478, 14.478, come on, Aynesworth, 0.478 degrees, okay? Now I've got to take the sine of it. So second step, I've got to take the sine of 14.478 degrees and get a value. Okay, so let's do that. So sine, you input your angle, 14.478, and this is rounded, so no, this is not totally exact. It's just giving you guys an idea. And notice I get 0.25, 0.25. There we go. And notice that notice that we get 0.25. We get the input. Okay, there we go. Number 6, let's take a look at this guy. So the graph of the inverse tangent is shown. Okay, again, this is the same thing as arc tangent of x right here. Two different notations that mean the same thing, and it says find the coordinates of A. So here we know it's going to be -1 comma something. So notice that this is your input. -1 is your input. So it's going to be, well, it's going to be -1 comma something, right? So how do we do this? So the input is -1. So if I just take the function given, we're given the inverse tangent of x here, and I input -1. So I get y is equal to the inverse tangent of -1. This is a negative number here, obviously. And the restriction for tangent, if you guys recall from what I just said earlier, okay, it returns only one value. And remember, the restriction on tangent is from -pi halves to pi halves. So we're looking for either a quadrant 1 or quadrant 4 angle. In this case, it's negative, so we're looking for a quadrant 4 angle. Okay? And then what angle gives you that? Well, let me see. We know from basics here, the tangent of phi force gives you 1, right? But we're looking for an angle in quadrant 4. So this is not equal to pi force because that's quadrant 1. It's got to be equal to negative pi force because that's in quadrant 4. So negative pi force. That's our quadrant 4 angle. And that makes sense. If you look at the y-axis here, okay, between 0 and negative pi halves, well, guess what? That's negative pi force. That makes sense. All right. Number 7, I'm not going to re-explain. because I've already explained that in the lesson here. So let's go to number 8 here. Okay, so Kimani here was asked to evaluate this expression. His answer and explanation are given below. He thinks it's equal to negative pi fourths because the inverse cosine function undoes, okay, the cosine function. So the output must be the same as the input, original input. Do you agree or disagree? So let's go ahead and, this is kind of like the, we did this in the lesson here, actually, in the check for understanding, but let's go through it again. Okay, so we start off with the inner part of the function. So let's do that. Let's go down here and start off with this part. So let's evaluate the cosine of negative pi fourths right here, and let's get a number. Okay, now just as a little picture here, negative pi fourths is a clockwise rotation. Just so that you know, it's quadrant 4. Now, coterminal with that, okay, right here is 7 pi fourths. That's coterminal. So the equivalent expression, if we want to rewrite it in something more familiar here, is the cosine of 7 pi fourths, which you should know. This number here is on the unit circle. Okay, this is quadrant 4. And as you guys know, cosine is positive there. So this is equal to the cosine of pi fourths, its reference angle. And as you guys know, if you draw your little 45, 45, 90 here, 1, 1, root 2, the cosine, the cosine of pi fourths, which is 45 degrees, is 1 over add 2, or root 2 divided by 2. Okay. All right, so now we have to take the inverse cosine of that. So now we apply the inverse cosine of our answer. Okay, right here, root 2 over 2, which is a positive number. And if you take the inverse cosine of a positive number, remember the restriction. Okay, the restriction is from 0 to pi. So again, the restriction on this, let me just refresh your memory here, is from 0 to pi, which puts us in either quadrant 1 or quadrant 2. And because it's positive, we're looking for quadrant 1 angle. So this has to be equal to, well, what? The inverse cosine of rad 2 over 2. You're thinking of an angle that produces that number. And because we already did that, this has to be pi fourths because, why? Because the cosine of pi fourths equals rad 2 over 2. Remember, when you take the inverse cosine of a number between negative 1 and 1, all right, and root 2 over 2 is between negative 1 and 1, it sends you back to the angle that it comes from. So notice here, notice that this right here is not the same as this right here, okay? So not equal. Okay, so I disagree. It says, do you agree with his answer? No. Okay, all right, they're not equal. Now, there you go. So the inverse cosine of an angle doesn't always give you that input value, so be very careful there. All right, consider the following. What do we got going here? How many solutions are there for the equation? Okay, so as we talked about in class here, equations of this type, you know, if you look at, if this is y1 and this is y2, so if you look at y1 or y equals sine of theta here, or sine of x, because that's what I'm going to input in Desmos in a second. And when is it equal to negative 1/2? Well, which is a horizontal line. Well, you're going to find out it has an infinite many solutions. Let's go to Desmos real quick, and let's just put the numbers in, just so you can see them. I did this in class, but let's do it again. So y equals sine x. Desmos is really, really cool because you can learn a lot from it. So I'm just going to type in, let's go from negative 2 pi to 2 pi, just so you can see, not 2 pi, let's go to 10 pi, just so you can see part of the function here, and let's do a step of pi halves. So pi divided by 2, you have to make it look good here. All right, so you can see how it oscillates forever, right? It oscillates forever, but when is it equal to negative 1/2? Well, you just type it in, so y equals negative 1 divided by 2. And you can see that this horizontal line at negative 1/2 intersects the sine function like at many different values. Okay, so I was just screenshotting right there. So this right here, because this sine function, all right, oscillates forever, and as I was saying here, it oscillates forever. It intersects. So this blue line here is y equals -1/2. The red curve here is your sine function, as you guys know, sine x right here, and the intersection points right here, the intersection points are the solutions, all right? And it has an infinite number of solutions. So sine equations involving trig functions, okay, they have an infinite number of solutions. Now, when you're asked to take the inverse sine of some number right here, you're getting one value. Okay, you're looking for one value because sine inverse functions are restricted. Okay, so remember on this one, the restriction again is from -pi halves to +pi halves. So you're looking for an angle in either quadrant 1 or 4. And because this is a negative number, you're looking for a quadrant 4 angle. Okay? And so the inverse sine of -1/2, let me see. So if you draw a little 30, 60, 90 here, 30, 60, 90, and you put your values in, we know that the sine of pi6 is equal to 1/2. We know that. And in quadrant 4, the sine of -pi6, okay, should have the same but opposite value. So at -1/2. So this right here, your theta, you're looking for an angle here because the inverse sine gives you an angle, is -pi6. Okay, so this right here says how many solutions are there? One single value. Okay, so instead of having an infinite number of solutions like an equation has, because this is an equation, notice right here, and then this right here is really just an expression here, you get only one value. So only one unique, all right, value. So they're different. Okay, equations have an infinite number of solutions. All right, when you take the inverse sine or inverse cosine or inverse tangent of some real number here, you're looking for a unique angle in the restricted domain, okay, or in the restricted range. So there you go. That I think that's all your homework. All right, so hopefully that helped you out. All right, and hopefully you guys work hard, do your best, and I'll see you in class. This is Mr. Aynesworth. You guys take care.